Dear students, we shall understand traveling salesman problem using least cost branch and bound method. First, we shall understand what is traveling salesman problem. In traveling salesman problem, there are n cities and a traveling salesman. The traveling salesman should start from a source city and he should travel through all the other cities only once and at last to travel back to the source city. But he should travel in such a manner that the total traveling cost or the distance should be minimum. I think we will take an example. Here I have taken the cities as Bangalore, Chennai, Mumbai and Hyderabad. We will explore all the possibilities. From Bangalore, you can go to Chennai. Chennai, there are two options, either Mumbai or Hyderabad. Bangalore to Chennai, Chennai to Mumbai, there is only one possibility, Hyderabad and back to Bangalore. Similarly, Bangalore to Chennai, Chennai to Hyderabad, there is only one possibility, Mumbai and back to Bangalore. Okay. Next, Bangalore to Mumbai. From Mumbai, there are only two possibilities, either Chennai or Hyderabad. Bangalore to Mumbai, Mumbai to Chennai, there is only one possibility, Hyderabad and back to Bangalore. Similarly, Bangalore to Mumbai, Mumbai to Hyderabad, there is only one possibility after Chennai and back to Bangalore. The last option from Bangalore is Hyderabad. From Hyderabad, there are two possibilities, Chennai and Mumbai. Bangalore to Hyderabad, Hyderabad to Chennai, there is only one possibility, Mumbai and back to Bangalore. Similarly, Bangalore to Hyderabad, Hyderabad to Mumbai, there is only one possibility, Chennai and back to Bangalore. So these are the only possibilities for these traveling salesmen. Now we shall attach the costs also. Bangalore to Chennai, it is 350. Chennai to Mumbai, it is 1400. Mumbai to Hyderabad, it is 700. Hyderabad to Bangalore, it is 600. So the total cost is 3050. Similarly, we will attach the cost for all the other cities also. You can just see the graph for the distances and compute the total distances also. Yes. Now, there are only 6 possibilities here. So we have found out the cost for all the 6 possibilities and the smallest among them is 2750 and there is one more solution 2750. So the best solution for the traveling salesman with the minimum cost is Bangalore to Chennai, Chennai to Hyderabad, Hyderabad to Mumbai, Mumbai to Bangalore. That comes around 2750. There is one more solution, Bangalore to Mumbai, Mumbai to Hyderabad, Hyderabad to Chennai, Chennai to Bangalore again. That also is 2750. Meaning, when there are 4 cities, we had 6 different possibilities. We found the answers for all the 6 different possibilities and found out the minimum among them. So when it is 4 cities, yes, this is fine. If there are 40 cities, if there are 400 cities, can we do like this? No, the number of options will be very, very huge. It will become exhaustive. We cannot find the answers for all the possibilities and then come to the minimum cost. No, that is not possible. We need a method which directly gives us the best solution, and for that we use the least cost branch and bound method. I think directly we should go to the method. Here we shall consider the following graph. So this is the graph. I have taken 5 vertices. So many edges are there. First we will write down the cost matrix for this graph. Same city to same city we consider infinity. There is 1 to 1 is infinity. Like that 2 to 2, 3 to 3, 4 to 4, 5 to 5, infinity. Now 1 to 2, just observe the graph. It is 14. 1 to 3, it is 4. I think you can observe the graph and we will just write down the distances from the vertices. Yes, this is the cost matrix for the given graph. Now we shall go to the next step, the first step of solving the problem. So this is the cost matrix that we got. Just now we wrote the cost matrix for the given graph. So this is our cost matrix. The first step is to get a reduced matrix by reducing the cost matrix. How to reduce the cost matrix? To reduce the cost matrix, we have to do row reduction and also we have to do column reduction. To do row reduction, find the minimum number in each row and this number is subtracted from all the numbers in that row. I think we shall do it, then you will understand easily. So this is our cost matrix. First we will write down the cost matrix, all the elements of the cost matrix. Yes, this is our cost matrix. Now consider the first row. In the first row, what is the minimum element? 4. Yes, 4 is the minimum element. Now 4 should be subtracted from all the other elements of the first row. That is infinity minus 4 is infinity only. 14 minus 4 is 10. Yes, change it. 4 minus 4 is 0. 10 minus 4, 6. 20 minus 4, 16. So the minimum element in the first row was 4 and 4 is subtracted from all the elements of the first row. Let us come to the second row. What is the minimum element in the second row? 7. So we have to subtract 7 from all the elements of the second row. 14 minus 7, 7, infinity, it is infinity only. 7 minus 7, 0. 8 minus 7, 1. 7 minus 7, 0. What is the minimum element in the third row? 4. So we have to subtract 4 from all the elements of the third row. That is 4 minus 4, 0. 5 minus 4, 1. Infinity minus 4, infinity only. And 4 minus 4, 0. 16 minus 4, it is 12. Next, come to the fourth row. In the fourth row, what is the smallest element? 2. So 2 should be subtracted from all the elements of the fourth row. So 11 minus 2, 9. 7 minus 2, 5. 9 minus 2, 7. Infinity minus 2, infinity only. 2 minus 2, 0. Good. Now fifth row, what is the smallest element? 4. So we have to subtract 4 from all the elements of the fifth row. 18 minus 4, 14. 7 minus 4, 3. 17 minus 4, 13. 4 minus 4, 0. So we have reduced all the rows. Now the row reduction cost is 4 for the first row, 7 for the second row, again 4 for the third row, 2 for the fourth row, and again 4 for the fifth row. So what is the total row reduction cost? It is 21. Very good. We have reduced the rows. The row reduction cost is 21. Now, to do column reduction, find the minimum number in each column and this number is subtracted from all the numbers in that column. But when we are doing column reduction, we should not consider the original cost matrix. We should consider the matrix after row reduction. That is, just observe. Yes. We are considering the matrix after row reduction, not the original cost matrix. After row reduction, whatever matrix we get, that we are considering. Yes. Now, consider the first column. What is the minimum element in the first column? 0. So, minimum element is 0. When you subtract 0 from all the elements, it will be same. Therefore, 0 only. What is the minimum element in the second column? 1. Yes. 1 should be subtracted from all the elements. Yes. 10 minus 1 is 9. Infinity minus 1, infinity. 1 minus 1, 0. 5 minus 1 is 4. 3 minus 1 is 2. Very good. Second column. Third column, the minimum element is 0. So all the elements will remain the same. Fourth column, the minimum element is 0. So all the elements will remain the same. Fifth column, the minimum element is 0. Therefore all the elements will remain the same. So we have reduced the columns also. Now column reduction cost is 0 for the first column, 1 for the second column, again 0 for the third column, 0 for the fourth column, 0 for the fifth column. So totally it is 1. So the column reduction cost is 1. Now, what is the reduction cost totally? Row reduction cost plus column reduction cost. In our case, it is 21 plus 1, it is 22. So, we have this reduced matrix also. Whatever, after column reduction, whatever matrix we get, that is the reduced matrix. And the reduced cost is 22. So, this is our reduced matrix and this is our reduced cost. Very good. This is important. This is the reduced matrix and this is the reduced cost. Next, we shall go to the next step. Now, we should consider the reduced matrix. Last step, whatever reduced matrix we get, we should consider that. I am going to write the elements of the reduced matrix. Yes, this is our reduced matrix and the reduced cost is 22. So the cost matrix value 22 for this reduced matrix. Yes, very good. Now, this is node 1. Node 1, there are 4 possibilities from 1. From 1, either you can go to 2, 3, 4 or 5. There is 1 to 2, 1 to 3, 1 to 4, 1 to 5. There are 4 possibilities. In general, we compute the reduced cost for each node corresponding to edge I comma j. In general, we consider edge I comma j in the state space tree as follows. See, in this particular case, we have 4 edges, 1 to 2, 1 to 3, 1 to 4, 1 to 5. In general, when the edge is I comma j, how to do? When the edge is I comma j, change all the entries in row I and column j to infinity to avoid any edges leaving I or entering j. Fine. Second step, j comma 1 should also be made infinity. Very good. Next, we have to reduce the rows and columns in the resulting matrix. But only thing is, if all the elements in a row is infinity, we don't do anything. If all the elements in a column is infinity, we don't do anything. With an example, it will be more clear. So, before going to the example, the reduced cost for the node corresponding to edge I comma j. This again is very important. Reduced cost at node j plus cost of I comma j plus reduced cost at node I. This is the formula. Anyway, with an example it will be more clear, don't worry. First we shall consider node 1 comma 2. There are 4 possibilities from node 1. 1 to 2, 1 to 3, 1 to 4, 1 to 5. First we are taking 1 to 2. That is edge 1 comma 2. Now, when the edge is 1 comma 2, row 1 and column 2 entries should be made infinity. 2 to 1 also should be made infinity. Very good. Now, same vertex to same vertex, it is infinity. Yes. Row 1, all the entries should be made infinity. Yes, row 1. Yes. Column 2, all the entries should be made infinity. Yes. 2 to 1, infinity. Yes, very good. We have done this much. After that, whatever values are there in the node 1, you just copy them exactly the same. That is 2 comma 3, it was 0 there, copy down 0. 2 comma 4, 1, yes 1. 2 comma 5, 0, 0. So copy the remaining entries from the reduced matrix. That is 0, 0, 12. Yes. So we made row 1 infinity, column 2 infinity, 2 comma 1 infinity, and copied the remaining elements from the reduced cost. We get this. Now we have to reduce this matrix. How to reduce? Row reduction, column reduction. Yes. We shall reduce this matrix. Now consider the first row. All the elements are infinity. When all the elements are infinity, we need not have to worry. Second row, 0 is the minimum element, and when 0 is minimum element, no change. Third row, 0 minimum element, no change. Fourth row, 0 minimum element, no change. Fifth row, 0 minimum element, no change. Now we should come to the column. First column, 0 is the minimum element, therefore no change. Second column, all the elements are infinity, we need not have to worry. Third column, 0 is the minimum element, you need not have to worry. Fourth column, again 0 is the smallest element, you need not have to worry. Fifth column, again 0 is the minimum element. So totally the reduced cost is 0 only. So it has become red. That is the total cost. Reduced cost for node 1 comma 2 is 0. Now reduced cost for node 1 comma 2 is 0. We have to find out the cost for 1 comma 2 because the edge is 1 comma 2. Therefore the cost of 1 comma 2 in the reduced matrix. So what is 1 comma 2? 9. Yes, you see this matrix, it is 9. 0 plus 9 plus what is the reduced cost? 22. Yes, 22. So 22 plus 9 is 31. So we have got the value for node 1 comma 1 2, it is 31. Let us do the same thing for node 1 3. Yes, now the edge is 1 comma 3. Again the same thing. Now row 1 and column 3 entry should be made infinity. 3 to 1 should become infinity. Yes, row 1 should become infinity. Yes. Column 3 should become infinity. Yes. 3 comma 1 should become infinity. Yes. And remaining values you copy down. Just observe. It is just copying. the values from there. 0, 12. Yes. After this, we have to do row reduction and column reduction. Yes, we will reduce this matrix. Consider the first row, all elements are infinity, no need of doing anything. Second row, 0, so no change in the second row. Third row, 0, no change. Fourth row, minimum element is 0, no change. Fifth row, minimum element is 0, no change. Now we shall come to the first column. In the first column, the minimum element is 7. Therefore, the reduced cost, you make it 7. Yes. And also, from the first column, 7 should be subtracted from all the elements. Therefore, 7 minus 7 is 0, 9 minus 7 is 2, 14 minus 7 is 7. Second column, 0 is the minimum element, no change. Third column, all the elements are infinity, no need of doing anything. Fourth column, minimum element is 0, no change. Fifth column, minimum element is 0, no change. Therefore, we have done the row reduction and we have done the column reduction, and the reduced cost is 7. So, we have got the reduced cost for 1, 3 as 7. Now, we should find what is the cost of 1, 3 in the reduced matrix. So, what is the cost of 1, 3? 0. It is 0. So, 7 plus 0. Plus, what is the reduced cost? 22. 22. So, 22 plus 7 is 29. Very good. Next, we should do for node 1, 4. That is edge 1, 4. So, row 1 and column 4 entry should be made infinity. 4, 1 should be made infinity. So, row 1 should become infinity. Yes. Column 4 should become infinity. Yes. 4, 1 infinity. Yes. Remaining values you just copy down. Just observe, I am just copying the same elements from that reduced matrix. Yes. Now we have to do row reduction. First row, all the elements are infinity, no need to worry. Second row, 0 is the minimum element, no change. Third row, 0 is the minimum element, no change. Fourth row, 0 is the minimum element, no change. Fifth row, 2 is the minimum element. Therefore, the reduced cost, you should make it 2. And 2 should be subtracted from all the elements of the fifth row. 14 minus 2 is 12. 2 minus 2 is 0. 13 minus 2 is 11. And remaining infinity minus 2 is infinity. Infinity minus 2 is infinity. So, row reduction is over. Next column. First column, 0 is the minimum element, no change. Second column, 0 is the minimum element, no change. Third column, 0 is the minimum element, no change. Fourth column, all the elements are infinity, we should not do anything. Fifth column, 0 is the minimum element, no change. So we have done the column reduction also. So after reducing the columns and the rows, the final reduced cost for 1, 4 is 2. Yes, we have got the reduced cost 2. Now, what is the value of 1, 4 in the reduced matrix? It is 6. You can just see 6. So 6 should be added here. Plus the reduced cost is 22. Yes, add here. So 22, it is 30. Plus 6 plus 2 is 30. Fine. Next we shall do for node 1, 5. Row 1 and column 5 entry should be made infinity. 5, 1 should be made infinity. Yes, very good. Row 1, it should be made infinity. Yes, row 1, infinity. Column 5, infinity. Yes, very good. And 5, 1 also infinity. Now, you just copy down the elements. Very good. Now, we have to do row reduction. Yes, we will reduce this matrix. First row, all the elements are infinity. We need not have to do anything. Second row, the minimum element is 0. Yes, no change. Third row, the minimum element is 0. No change. Fourth row, the minimum element is 4. Therefore, we should make it 4 here, the reduced cost. Then 4 should be subtracted from all the elements of the fourth row. Therefore, 9 minus 4 is 5. 4 minus 4 is 0. 7 minus 4 is 3. Fifth row, 0 is the minimum element, no change. Now column reduction. First column, 0 is the minimum element, no change. Second column, 0 is the minimum element, no change. Third column, 0 is the minimum element, no change. Fourth column, 0 is the minimum element, no change. And fifth column, all the elements are infinity, we should not do anything. So, totally the reduced cost is 4. Okay, for node 1, 5, the reduced cost is 4. Plus, what is the cost of 1, 5 in the reduced matrix? It is 16. Yes, 16. Plus what is the reduced cost? 22. So 4 plus 16 plus 22 is 42. So now we have got four different values. This is the reduced matrix, and also try to understand for node 1 comma 2 this is the reduced matrix, 1 comma 3 this is the reduced matrix, 1 comma 4 this is the reduced matrix, and 1 comma 5 this is the reduced matrix. So we should know the reduced matrix and their costs also. So 1 comma 2 it is 31, 1 comma 3 it is 29, 1 comma 4 it is 30, 1 comma 5 it is 42. All these values we require. Now we write a small partial space tree. We started from 1, 2, the cost was 31, 1, 3, the cost was 29, 1, 4, the cost was 30, 1, 5, the cost was 42. Now, among these four values, which is the minimum? Yes. In least cost branch and bound, we have to explore and branch the node with least cost among all the leaf nodes. There are four leaf nodes here with the values 31, 29, 30 and 42. Which is the minimum? 30 is the minimum. So now see here, least cost among 31, 29, 30 and 42 is 29. Therefore, we have to explore the node 1, 3. That is edge 1, 3. We will explore 1, 3. When we have to explore 1, 3, we should take the reduced matrix for node 1, 3. That we already made a note. So, reduced matrix for 1, 3. I'll just write down the reduced matrix for 1, 3. This is the reduced matrix for 1, 3. Yes. Okay. Now, for node 1, 3, what are the possibilities? 1, 3 are already over. Therefore, 1, 2, 3. Either you can go to 2, 4 or 5. That is 1, 3, 2, 1, 3, 4 or 1, 3, 5. Three possibilities are there. Let us explore them. And the reduced cost was 29. That is the minimum cost. Now, node 1, 3, 2. Yes, node 1, 3, 2. That is edge is 3, 2. Carefully understand. Even though the node is 1, 3, 2, edge is 3, 2. And when the edge is 3, 2, row number 3 and column number 2 entries should become infinity. 2 to 1 should become infinity. Yes. Now, row 3, yes, infinity. Column 2, infinity. Yes. 2, 1, infinity. Very good. Remaining values just copy down from the matrix. The reduced matrix for node 1, 3. You just copy down the elements. Very good. Now, we should reduce this matrix, row reduction and column reduction. Now, first row, all the elements are infinity, therefore we need not have to do anything. Second row, minimum element is 0, therefore we need not have to do anything. No change. Third row, all the elements are infinity, nothing to be done. Fourth row, minimum element is 0, no change. Fifth row, minimum element is 0, no change. Fine, row reduction is over. Next, column reduction. Come to the first column. In the first column, the minimum element is 2, therefore we should add it. It should be 2, and 2 should be subtracted from all the elements. Anyway, 3 infinities minus 2 is infinity only. 2 minus 2 is 0. 7 minus 2 is 5. Second column, all the elements are infinity, no need of doing anything. Third column, all the elements are infinity, nothing doing. Fourth column, the minimum element is 0, no change. Fifth column, the minimum element is 0, no change. Therefore, the total reduced cost for the node 1, 3, 2 is 2. Very good. We have computed the total reduced cost. Next, what is the cost of 3 to 2 in this reduced matrix for node 1, 3? So just see here 3 to 2. What is the cost? It is 0. Yes, 0. Plus what is the reduced cost for the node 1, 3? It is 29. Here we have written 29. So it is 31. 29 plus 2 is 31. So 1, 3, 2 we have finished. Next we have to do for 1, 3, 4. And the edge is 3, 4. And row 3 and column 4 entries should be made infinity. 4 to 1 should be made infinity. Very good. Yes. Row 3 should be made infinity. Column 4 should be made infinity. Yes. And 4, 1 is infinity. Remaining elements just copy down from the reduced matrix for node 1, 3. Just observe, I am just copying down the elements. Yes. Now we have to do the row reduction and column reduction. Now, just see, first row all the elements are infinity, therefore you need not have to do anything. Second row, the minimum element is 0, no change. Third row, all the elements are infinity, need not have to do anything. Fourth row, the minimum element is 0, you need not have to do anything. Fifth row, the minimum element is 2. Therefore, that should be added to the reduced cost 2, and 2 should be subtracted from all the elements of the fifth row. So 7 minus 2 is 5. 2 minus 2 is 0. Infinity minus 2 is infinity only. All the three infinities will remain as infinities. So therefore, row reduction is over. Now column, first column the minimum element is 0, no change. Second column minimum element is 0, no change. Third and fourth column infinities, we need not have to do anything. Fifth column, it is 0, no change. Therefore, the total reduced cost is 2. Plus, what is the cost of 3 comma 4 in the reduced matrix for node 1 comma 3? Just observe, 3 comma 4 is 0. So add it. Plus, what is the reduced cost for the reduced matrix of node 1 3? It is 29. So 29 plus 2 is 31 again. Okay. Next, last one, node 1 3 5. That is for edge 3 comma 5. And edge 3 comma 5, row 3 and column 5 entry should be made infinity. 5 comma 1 should be made infinity. Yes. Row 3 infinity, column 5 infinity, yes, and 5 comma 1 infinity, and all the remaining values you copy from the reduced matrix for node 1 3. Yes, now we have to do row reduction. We have to reduce this matrix, and column reduction also. So first row, all the elements are infinity, we need not have to do anything. Second row, the minimum element is 0, no change. Third row, all the elements are infinity, nothing doing. Fourth row, the minimum element is 2. Therefore, we have to take down the 2, and 2 should be subtracted from all the elements of the fourth row. That is 2 minus 2 is 0, 4 minus 2 is 2, and remaining infinity will remain infinity only. Fifth row, the minimum element is 0, no change. So row reduction is over. Next column reduction. First column, minimum element is 0, no change. Second column, the minimum element is 2. Therefore, 2 should be added. Previously, it was 2. 2 plus 2 is 4. It will become 4. And 2 should be reduced from, 2 should be subtracted from all the elements of the second column. Yes, 2 minus 2 is 0. 2 minus 2 is 0. Fine. Third column, all the elements are infinity. No need of doing anything. Fourth column, the minimum element is 0. No change. Fifth column, all the elements are infinity. We need not have to do anything. So total reduced cost for the node 135 is 4. Very good. Now, what is the cost of 3 comma 5 in the reduced matrix for node 1 3? 3 comma 5. It is 12. Yes, 12. Plus, what is the reduced cost for node 1 3? It is 29. 29. So totally it will become 45. 45. So we got three values. For 132 we got 31, 134 we got 31, 135 we got 45. We got three values. So remember all these three values and the reduced matrix. This is the reduced matrix for 132, reduced matrix for 134, reduced matrix for 135. Now we shall write the state space tree. This already you know we have done. We had explored 1 3 and we have got three different values here. 132, 134 and 135. Now among all the leaf nodes we have to find the minimum. Just observe here. Among all the leaf nodes find the least cost node to explore and branch. That is what is least cost branch and bound. So now 31, 31, 31, 45, 30 and 42. So which is the minimum? 30 is the minimum. Among all the leaf node values 31, 31, 31, 45, 30 and 42, 30 is the least cost. So we have to explore 1 comma 4. We have to explore the branch from 1 comma 1 4 from the node 1 4. Now when we have to explore 1 4 node 1 4, we have to write the reduced matrix for node 1 4. So we write the reduced matrix for node 1 4. You remember we had run the reduced matrix for node 1 4. That matrix we have to consider. Yes, this is the reduced matrix for node 1 4. And when it is 1 4, again we have three possibilities here. 1 to 4, 4 to 2, 4 to 3, 4 to 5. Three possibilities are there. First we shall consider, and the reduced cost is 30 as you know. First we shall consider 142 and the edge is 42 here. When the edge is 42, row number 4 and column number 2 entry should be made infinity, and again 2 to 1 should be made infinity. Very good. Just observe here, row number 4 infinity, column number 2 infinity. Yes, and 2 to 1 infinity. Very good. And remaining values copy down from the reduced matrix for node 1 4. Yes, I am just copying. Observe. Yes. Now we have to reduce this matrix. So first column, all the elements are infinity, no need of do anything. First row, I'm sorry. First row, all the elements are infinity, you need not have to do anything. Second row, the minimum element is 0, no change. Third row, the minimum element is 0, no change. Fourth row, all the elements are infinity, no change. And fifth row, minimum element is 11, 11 should be taken and 11 should be subtracted from all the elements of the fifth row. That is, 12 minus 11 is 1, 11 minus 11 is 0, and infinity will remain infinity only. So row reduction is over. Next we shall go to the column. First column, the minimum element is 0, no change. Second column, all the elements are infinity, nothing doing. Third column, the minimum cost is 0, no change. Fourth column, all the elements are infinity, nothing doing. Fifth column, the minimum element is 0, no change. So totally the reduced cost for the node 142 is 11. Very good. Now, what is the cost of 4, 2 in the reduced matrix for node 14? So just see what is the cost of 4, 2. It is 4. It is 4. So we have to add here. Plus what is the reduced cost of node 14? It is 30. We add 30 also. So this will become 45. Very good. 142 we got 45. We got a reduced matrix for 142 and the cost of 142 is 45. Next we shall do for 143. Row number 4 and column number 3 should be infinity. 3 to 1 should be 1. Yes. Row number 4 infinity. Column number 3 infinity. 3 to 1 infinity. The remaining values just copy down from the reduced matrix of node 1, 4. Just observe, I am just copying the elements. Very good. Now we have to do the row reduction and column reduction. Yes. First row, all the elements are infinity, nothing doing. Second row, the minimum element is 0, no change. Third row, the minimum element is 0, no change. Fourth row, all the elements are infinity, nothing doing. Fifth row, minimum element is 0, no change. So row reduction is over. Come to the column. In the first column, the minimum element is 7. So take it to the reduced cost. So 0 becomes 7. And 7 should be subtracted from all the elements of the first column. Infinities will not change. 7 minus 7 is 0. 12 minus 7 is 5. Second column, minimum element is 0. No change. Third and fourth column, all the elements are infinity. Nothing doing. Fifth column, the minimum element is 0. No change. Therefore, the total reduced cost for the node 143 is 7 plus what is the cost of 4, 3 in the reduced matrix for node 114. Node 14. You just see. Yes. 4, 3 it is 7. So 7 should be added here. For the edge 4, 3 it is not 1, 4. It is 4, 3 because we are considering the edge 4, 3. Therefore, it is 4, 3. It is 7. Plus, what is the reduced cost? It is 30. So, it is 44. We got 44. Now, 1, 4, 5. Edge. We should consider the edge 4, 5. It is not 1, 4. It is 4, 5. Now, row 4 and column 5 entry should be made infinity. 5, 1 should be made infinity. Yes. Row 4 infinity. Very good. Column 5 infinity. Very good. 5, 1 infinity. Very good. The remaining values just copy down from the reduced matrix of node 1, 4. Very good. Now we have to do the reduction. Row reduction. First we will do the row reduction. First row, all the elements are infinity. Nothing doing. Second row, minimum element is 0, no change. Third row, the minimum element is 0, no change. Fourth row, all the elements are infinity, nothing doing. Fifth row, the minimum element is 0, no change. Next we shall come to the columns. First column, the minimum element is 0, no change. Second column, the minimum element is 0, no change. Third column, the minimum element is 0, no change. Fourth and fifth column, infinity, nothing doing. Therefore, the minimum cost is 0 only. So what is the reduced cost here? Not the minimum cost, it is the reduced cost. For node 145, it is 0. Now we should consider the cost of 4 to 5, not 1 to 4, 4 to 5 in the reduced matrix of node 1, 4. What is the cost of 4 to 5? 0. Plus what is the cost of reduced cost for the reduced matrix for node 1, 4? It is 30. Yes. So we get 30. So this is the reduced matrix for node 142, 143, 145. Now we should remember these values and the reduced matrices also. Next we shall find the partial state space tree. Yes, till here all of you know already we have done. 1, 3 also we had explored. Now we had explored 1, 4 and these are the values. 1, 4, 2 it was 45, this was 44 and this was 30. Now among all the leaf node values, find the least cost node to explore the branch. So what are the leaf node values? 31, 31, 31, 45, 45, 40, 30 and 42. So what is the minimum among all of these values? 30 is the minimum. So 30 is the least cost and 30 is the least cost for node 145. So we should explore 145. If we have to explore 145, we require the reduced matrix for 145. So we write the reduced matrix for 145 and the edge is 4, 5. This is the reduced matrix. We should remember the reduced matrix. That matrix I am writing. Reduced matrix for 145 and the reduced cost is 30. Now for the node 145, there are only two possibilities. 1 to 4, 4 to 5, 5 to 2 or 5 to 3. There are only two possibilities. So we should explore both the possibilities. So this is 1 to 4, 4 to 5, 5 to 2. That is for edge 5, 2. Yes. When the edge is 5, 2, row 5 and column 2 entries should be infinity. 2 to 1 also should be made infinity. Yes. Row 5 infinity. Yes. Column 2 infinity. Yes. And 2 to 1 infinity. Yes. Now for the remaining, you copy down the values from the reduced matrix of node 145. Yes. Now we have to reduce the rows and the columns. Now in the first row, all the elements are infinity, nothing doing. Second row, minimum element is 0, no change. Third row, minimum element is 0, no change. Fourth row and fifth row, all the elements are infinity, nothing doing. Again, first column, the minimum element is 0, no change. Second column, all the elements are infinity, nothing doing. Third column, the minimum element is 0, no change. Fourth and fifth columns, all the elements are infinity, nothing doing. Therefore, the total reduced cost for the node 1452 is 0. 0. Plus, what is the cost of 5, 2 in the reduced matrix for node 145? Yes, what is the cost? 5, 2. Okay, just is 0. Therefore, you add 0. And what is the reduced cost? It is 30. Yes, 30. Next, we should consider 1453. Second option. Row 5 and column 3 entries should be made infinity and 3, 1 should be made infinity. Yes, very good. Row 5, yes, infinity. Column 3, infinity. 3, 1, infinity. Very good. Now, remaining elements you just copy down from the reduced matrix of 145. Yes. Now we should reduce the rows and the columns. Now, first row, all the elements are infinity, nothing doing. Second row, the minimum element is 7. So we should take that 7 and 7 should be subtracted from all the elements of the second row. 7 minus 7 is 0 and infinities will remain infinity. Third row, minimum element is 0, no change. Fourth and fifth row, all the elements are infinity, nothing doing. So row reduction is over. Next column. First column, the minimum element is 0, no change. Second column, minimum element is 0, no change. Third, fourth, fifth columns are infinity, nothing doing. Therefore, the total reduced cost for node 1453 is 7. Next, what is the cost of 5, comma 3 in the reduced matrix for node 145? So what is the cost? 5, comma 3? 11. Yes, 11. Plus what is the reduced cost? Is 30. Yes, 30. So it comes to 48. So we have got two 1452, one node, the cost is 30. Another node is 1453, the cost is 48. We should remember these two reduced matrices and the costs also. Now again, we shall go to the state space tree. Yes. Till here we are done. Now we explored 145. There is 1452 and 1453, 30, and this is 48. Same thing, among all the leaf node values, find the least cost node to explore and branch. So what are the leaf node costs? 31, 31, 31, 45, 45, 44, 30, 48, and 42. So what is the minimum among all the leaf nodes? 30, 30. For 1452, yes. Now we have to explore and branch from node 1452. If we have to explore the node 1452, we require the reduced matrix for node 1452. Therefore, we just write down the reduced matrix for node 1452. Yes, this is the reduced matrix for node 1452. We had made a note and we are writing that. Yes, very good. And now, from 1452, there is only one possibility, that is 14523, because only one vertex is remaining. 14523, yes, only one possibility is there, 14523, and the edge is 2, comma 3. Row 2 and column 3 entries should be made infinity, 3, comma 1 should be made infinity. Yes, row 2 infinity, column 3 infinity. Very good. 3, comma 1 infinity. And remaining values you copy from the reduced matrix of node 1452. Yes, very good. Now you can just observe all the elements of the matrix are infinity. Therefore, there is no question of reduction at all. So reduced cost will be 0 straight. Okay, reduced cost will be 0 straight because there is no question of reduction at all. When all the entries are infinity, nothing doing. 0 plus now. What is the cost of 2, comma 3? 2, comma 3 in the reduced matrix. Just see the reduced matrix for 1452. It is 0. 0. Plus what is the reduced cost for node 1452? It is 30. So this is 30. Very good. So we got the reduced matrix and this is the only possibility. This is the reduced matrix and the cost. Fine. Now we shall write the state space tree. Yes, you can just see, observe 1452 we explored and we got 30 again. Meaning, just observe among all the leaf nodes 31, 31, 31, 45, 45, 44, 30, 48 and 42. 30 is the least cost and that is for node 14523. 30 is the least cost. We have got the solution because only 5 vertices were there. We have got the solution. What is the solution? 14523 and again back to 1. The solution is as follows. 1 to 4, 4 to 5, 5 to 2, 2 to 3 and 3 to 1. This is the solution. Now we will find out the final cost also. So what is the final cost? You have to take the cost from the original graph. I think original cost matrix. If you remember at the beginning, we wrote the original cost matrix. A graph was given, a cost matrix was there. From there we have to take the value. What is the value of 1 to 4? 10. 4 to 5? 2. 5 to 2? It is 7. 2 to 3? It is 7. 3 to 1? It is 4. So what is the total cost? 30. So this is solution. The traveling salesman should start from 1, he should go to 4, he should go to 5, then he should go to 2, then he should go to 3, then again he should come back to 1. This will give the least cost, that is 30. This is the solution of this traveling salesman problem. Carefully understand, in this traveling salesman problem, the key is we branch from the node with the least cost. So we have to explore the state space tree and we have to explore that node with the least cost. Therefore, this is called as least cost branch and bound. Okay, that's the whole concept of traveling salesman problem. This looks a little difficult, but one or two times, one or two different problems you solve, this becomes very easy. This is quite interesting and quite easy also, traveling salesman problem using least cost branch and bound. I think all of you have understood. It is quite simple and easy also.